An employee charged $3,550 on his credit card to relocate for his first job. After noticing the interest rate for his balance was 15% compounded monthly, he stopped charging on the account. He wishes to pay off his balance in 2 years using automatic payments sent at the end of each month. What monthly payment must he make to pay off the account at the end of 2 years? Once we answer that, then we want to know how much total interest will he have paid. This is a present value problem. Any problem where you're dealing with loan payments is going to be a present value problem, so I've got the formula there. We have to figure out what all the letters are, what all the values are, and then do the calculation. So he's really built up a balance of $35.50, and that's like a loan from the credit card company, and he wants to pay it back. So the amount of the loan is always the present value. So that would be the $35.50. The amount he has to pay is what we're looking for. What monthly payment must he make to pay off the account at the end of 2 years? That's the periodic payment he has to make to get that loan paid off. So that's what we're looking for. The time in years, he wants to do it in 2 years, so T would be 2. The annual interest rate is 15%, which would be 0.15. That's a high rate, so he wants to get rid of that by paying off this thing as fast as possible. The number of compounding periods per year, it's monthly, so that would be 12 times a year. The interest rate per period, little I, is R, which is 0.15, divided by M, which is 12. If you do that on the calculator, you'll get 0.15 divided by 12 is 0.0125. And N is M times T. M is 12, T is 2, so that would be 24. And at this point it pretty much becomes plugging in and calculating. So we get 35.50 equals, capital R is what we're looking for, 1 minus the quantity 1 plus little I, which is 0.0125, raised to the power of minus n, which would be minus 24, all divided by little I, which is 0.0125. And now it pretty much becomes an arithmetic problem and playing with your calculator and getting all those things correct. So let's make some room and see if we can do that. We have 35.50 equals capital R times. Now we can do that quantity on the calculator. Should be no problem. Start here. We've got this number already in the calculator, so if we just say plus 1, we'll get the base. So the base is 1.0125. We want to raise it to a power, so we do the power button. And let's push it up higher so you can see it better. I hit the power button, but I'll do it again just so you can see. And then we want to take it to the negative 24 power. And as you probably know by now, you cannot type or enter a negative number directly in the calculator. You have to enter the positive value, 24, and there's a key with a plus minus on it that switches the sign. So if I put in 24, press the plus minus key, then all of a sudden I have negative 24 in there. Remember, that was the exponent, so now I hit equal to get that power. And I've got some sort of error, so let's just start over. 1.0125 raise 2, and then put in a positive 24, but make it negative by hitting plus minus and then hitting equal. So there we go. That's the entire base raised to the negative 24 power. But notice that the quantity here should be negative itself, and it's not, so now is another perfect time to hit plus minus again. That puts a minus in front, which is what we want. And the only thing in the numerator not dealt with is this plus 1, so we just say plus 1 equals, and that takes care of the entire numerator. So now we need to divide by whatever's in the denominator, which happens to be 0.0125 equals. So this quantity, 20.624 23451. That's what we get when we do that calculation. Now to solve for capital R, we need to divide both sides by this 20.6 and on quantity. So we get capital R is 3,550 divided by 20.62423451. Now here again, we're in the same situation you've probably been in before. We've got this number with lots of decimal places in the calculator, but we want to do a division of 3550 by that number. Normally when you do a division on the calculator, you type in the numerator, hit division, type in the denominator. However, that's a lot of decimal places. You could write it down, clear the calculator, do 3550 divided by, and then put it back in and hit equal. You could also choose to store that quantity in the memory so you can bring it back without having to type it back in. That would probably be somewhat of an improvement, because if you don't take enough decimal places when you write something down and type it back in, your final accuracy may not be to the nearest cent. Or you can use the little trick that I like to use, and that's using the fact that there's a button on here that I call the reciprocal button. It's 1 over x. It's the shift version of the key next to the left of the power key. It's 1 over x. That button flips a fraction upside down. So going back to my problem, I want to say 3550 divided by this big long decimal, but the big long decimal number is already in there and I don't want to clear it. So my trick is to divide it upside down. Instead of dividing numerator by denominator, I'm going to divide denominator by numerator. So I've got the denominator already in there, divide by the numerator, which is 3550, hit equal. Now I know that number's not right, but I also know that I can make it right by hitting the reciprocal button, which flips it upside down, and that puts it back the way I wanted it. So if you do shift button next to the power button, you get the reciprocal of what I actually calculated, and that's exactly what I wanted. So you don't have to use this little trick, but if you don't, you need to practice the way that you're going to do it and make sure that you get it correct. So that is the amount of money the employee would have to pay each month, or each yeah, it's monthly, in order to pay off his credit card debt. There was also another question. The other question asked for how much total interest was paid, and to answer that, you've got to think about what's happened. The interest is the difference between how much he actually paid in altogether and what he borrowed, which was $35.50. So how much did this employee actually pay in to the credit card company? Well, he or she paid $172.13 per month for 2 years. So I can tell you fairly quickly that he paid $172.13. He paid it 12 times a year for 2 years. In other words, he made 24 payments. If you want to be quicker about it, this number right here, 24, is going to tell you what that number gets multiplied by. But in any case, you can see now what your calculation has to be. This is another point of warning, and I'm just going to say this very quickly. There's a difference between what you have in the display here and what you wrote down, so you got to be careful here, because what you have here in the display is 172.1276006. Now if you take that and multiply it by 12 times 2, you may get a slightly different answer in the dollars and cents than you would if you just took 172.13 and did that. And the reason is this round off error can make a difference. Now which number should you use though? Are you going to use this number, the 172.13, or are you going to use what's in the calculator? In some of the other calculations, I told you that if you rounded it off too much, you'd be wrong to the nearest dollar and cent. But this is where you got to think about what's really going on. The credit card company is not going to take this payment from the employee every month. They're not going to take $172.1276006. They're going to round it off to the nearest cent, and this is the amount that the employee is going to send in to the credit card company each month. So it's this number that we should use, the rounded one, not the unrounded one, because in reality the person's not going to send in this huge decimal value as a payment every month. They're going to round it to the nearest cent. So this is one of the times when you need to use the rounded value, not the value in the calculator, and that's because reality steps in. In reality, the person's going to pay the credit card company this amount, not that amount each month. So the point being, you need to clear that display now and put in 172.13 and times that by 12 and then by 2, and you'll end up with $4,131.12. So the total that the employee paid to the credit card company is this amount. The employee owed, which is essentially the loan amount, it's the amount the credit card company loaned them, owed $35.50. And the difference between those two values is the interest. So all I need to do to finish this off to get the total interest that this employee paid is just subtract these two numbers. And the big number is already in the calculator, so I can just now say minus $35.50, and I figure out that the employee ended up paying $581.12 to the credit card company in interest.